Hey YouTube, it's been some time since the last video due to holidays and stuff like that. But what you have seen is that in the past 2 days we have released a new version 3.1. And as promised on Facebook, we'll create a video and show you the new features and functionality that has been added into the software. Of course, there is also a lot of changes on the background, stuff you don't see. And there are changes in the database to improve the reliability and performance of the database itself. But there are also a lot of new features added into the menus. So I'm going to take you through the steps of getting the charger added, going through the setup, explain all those new parameters to keep you up to date. Now, a lot of people asking, why are you not having a website? Well, there is a website, but creating a manual is a very time-consuming and tedious activity, and especially to keep it up to date. So I'd rather choose this media as a video to show you what is in the software and how to actually operate and what are the features associated with each parameter. It allows me to quickly publish new releases, but also keep you guys up to date without going through days and days of capturing screenshots and writing the descriptions into a website. Now, if somebody wants to do that and help me out, I'm absolutely open for any support. But for now, guys, this is it. You have a video, watch it maybe once, twice, or multiple times, because I will take you through all the parameters, and that should get you going for sure. All right, let's dive in. There are two ways to actually install the software. The first way is through the website for any update, and the second one is to do the auto update by the application itself. Now, if you navigate to the Megacell Monitor website and you go to downloads, you click the Megacell Monitor icon, it shows you an install button. You follow the instructions, and it's quite intuitive. There's not much to do here. You wait until it's downloaded, and when it's actually ready, it will pop up that this is an unknown published application. It's due to the software not yet being registered with Microsoft. We're getting that to a certain point, but this it's quite a tedious process for a single project. Now, when you have the app installed, before with an older version, you just click the icon and automatically the installer recognizes that there's a new release, and it will actually download it automatically. It shows also the same screen, that it's still not a recognized application. Just click on more info and then run anyway, and it will eventually start up the Megacell Monitor application. So what has changed, and that's what we're here for. The first thing you notice is that the startup of the application is slower than normal. And that is due to an automated backup of the database. As you can see here, it's starting the database. Actually, it's now making a backup. And if you go to the Connect and Exchange folder on your C drive, you will see that there are now additional folders created in the Connect and Exchange folder. And one of them is called Backup. Now, my database is 1.6 gigabytes in size, so it takes some time for the database backup to be completed. It basically compresses the database and then stores it in the backup folder. So when you have a large database and you think the system is hanging, actually it's not, but there's no way that I can report back on this process. The whole activity of zipping the file and compressing the database doesn't allow for callbacks. Most unfortunate, so I hope we can fix that at some point, but yeah, not at this moment. So be patient, especially when you have a large database. Now, the database I had already was pre-configured. So to make this one a experience that you have out of the box, we're going to delete the database from my drive and then restart the application. As you can see here, I'm just renaming my database. I don't want to lose it. Even though I have a backup, of course, I could have just deleted it and then unzipped the backup file, but this is easier. So I'll start the app and you will see that it checks, it comes up with the startup screen, and you'll see that the actual startup of the database is now quite fast. There's nothing to back up because it's completely empty. Now, over time, I've been adding a lot of tooltips to most of the elements in the application. As you can see here, this is the charge, discharge buttons, and when you hover over these buttons, you will automatically see what they do, and there's a small descriptive text that helps you understand what this button is going to do when you push it. Now we're going to extend that and expand on all those additional tooltips for ease of access. Now, when we started the app, let's go to the configuration panel, and most of you have already seen it, but let's go through it for those that are new. You have two sides of the simple view, one to add a charger and one to scan for your chargers. Adding means that you type in the IP address of the charger that you have, and then you click add, which works quite well. For a single charger, that's fine, but when you have multiple chargers, it might be a little bit of a cumbersome activity. So we have also a scan feature. The scan feature automatically recognizes your subnet. Normally you don't have to change this, but because I have like 512 hosts in my environment, I narrowed it down to the subnet that I actually needed where my chargers are in. And once you've scanned it, you see that I found 3 of them, and you can hit add. So the system automatically adds the chargers, and please be patient there. It takes some time for the communication to start. It needs to read the settings. If you go too fast, it'll automatically, if you go too fast and you click already on close, or you just stop this process, it might not complete correctly, and yeah, that's not great. Now on the on the right, you see the low voltage, the store voltage, and the max voltage. Now those are set for your charge process. The min voltage means it discharges up to that level and then it stops discharging. The store voltage is the voltage where your cells are stored when you want to keep them stored somewhere in a box or ship them. It's also for compliancy reasons, it can't be shipped fully charged or fully discharged. You need to have a certain level. And of course the max voltage is the voltage it goes through for charging. Now what you see me doing here is there are several ways to manipulate the parameters. When you do, you can either select a single charger and hit apply, or you can select nothing, and if you select nothing, it basically applies to all chargers. And as you can see here, when you do a nothing selected, it says, okay, web parameters that you're setting will apply to all. Now, when you want to receive messages, you can add an email address into this dialog box, and it'll automatically send you status updates of your charger to that particular email address, and ensures that when your charger is completed with a particular process, that you get informed. Now, set also your dymo labeler and hit test print to see if something comes out. We want to make sure that before we start the actual charge process, that all is working as expected. Now, as you can see here, the print has been sent to the print queue, but because my dymo label printer is powered off at the moment, it will show as an error, which is absolutely fine in my case because I haven't enabled it for the obvious reasons. During these videos, you don't want to have constantly all these labels be printed. Makes a little bit of a mess. So when you close the configuration screen, drag your charger fuse to the right location of your preference, and you see they're completely empty at the moment and you're good to go. Alright, let's discuss this main view. There are a few things that people already know. Out of the box, it's very intuitive. The first icon is to charge the battery. Below here we will have a few chargers. Now let me show you what happens. Let's add a single charger to it. So it's easier to explain. Okay, charger settings are loaded, so we're good to go. Now you can see here that this is the charge. So when you select any of the cell positions of a particular charger in this view, and you would have added the batteries into the charger on those slots, And when you click the charge button, it'll automatically start charging. Now the icon next to it, that is actually the discharge button. It does exactly what it says. You keep the selection in the bottom and you hit the discharge button and it automatically starts discharging the battery to the min voltage. Now the middle icon is for measuring capacity. Now the measuring capacity is a process. It basically charges the cell to the max voltage and then it discharges the cell all the way to the min voltage and measures the total capacity during the discharge cycle. Once that discharge cycle is completed, it brings the cell back to the store voltage and then the cell is done. Now, the reason that it brings it back to the store voltage is that eventually you will take it out of your charger and you want to ship it. For anyone that is doing the commercial aspect, you want to store it for a longer period of time. So there it goes to the 3.6 or 3.7 volt for store voltage. Now I hear a lot of people saying like, okay, but I want to do a self-discharge test. And the set point of 3.6 or 3.7 volts for the store voltage is not suitable. And you're right, but you have the ability to change that parameter in your settings panel, and you can change this one to 4.2, which means that it'll discharge to the minimum voltage and then it charges it all the way back to 4.2 volts. So that freedom you have to make sure that you charge it completely and then you put it aside for a couple of weeks and then actually see what the discharge is over time. Now the icon here is for starting the store charge, and that means that if you have like a lot of cells having different voltages and you want to make a cell pack or you want to ship the cells to someone else with a courier or whatever, you need to make sure that they are all on the same voltage, either for shipping or either for building your cell pack. So the easiest way to do that is you take all your cells, you add them into the charger, and then you hit this button, store voltage, and it will do two things. If any cell is above the set point for store voltage, it will discharge it and bring it to the store voltage. Anything that's too low will bring it up to the store voltage. So that allows you to quite quickly make sure that all your cells have the same voltage when you do a cell pack build. Of course, that is very, very preferable, especially if you do a 200p battery. You don't want to have a cell that's completely discharged and added into a cell pack that is fully charged or have a higher voltage. If you do so, once you add the nickel strip or you solder it, it immediately creates a rush-in current, either tripping your trace fuse or causing all kinds of other, not so funny things like sparks and maybe fire and whatever. So make sure all your batteries are on the same voltage when doing a cell pack build. Now this button, the red one, it's obvious. It'll do and stop any and all operations currently performed on the cells that you have selected. So either if it's charging or discharging or running a workflow or it's doing something else, when you hit this button it'll stop, no matter what. On the bottom you'll see from left to right the settings page, which you need for getting everything configured, your cell database, and this one is for your workflow. Now the workflow means that when you're going through a process of charging a couple of hundred cells, you want to have some workflow enabled, which is doing, for instance, a discharge, a rest, a charge, or capacity test, then a rest again, print a label, all kinds of things that you want to do on that particular cell. And when that workflow is completed, it will report done. You take the cell out of your charger, you put a new cell in, you don't have to touch anything, and it automatically restarts that workflow from the beginning. Very useful when you need to do a lot of batteries. You just put your software somewhere in the corner on a machine or a virtual machine, it doesn't really matter. You leave it running and you just only have to swap batteries. And in my case, I also print labels. So when the label is printed, I know that cell is done. chuck it onto the battery, take it out, put a new one in, and we move on. This button is for changing between simple and advanced mode. Now, the simple mode, as you can see, only shows the graphical representation of the charger, which is absolutely fine for beginners. You don't want to start messing with all kinds of parameters where you're not accustomed to. And I see a lot of questions coming in from users that are starting, like, and what do I need to set in the advanced panel? What does it do? What is my impact? Guys, when you're starting, stay away from the advanced features for now, and let's first get you started in charging batteries and building a pack and getting more accustomed to what happens in this process. And the system is already pre-configured with default parameters, so it will detect faulty cells. It will report back to you, and yeah, you're basically better off not tweaking too much in the beginning. Now, for those that are advanced, you can click this advanced button. You see also the E is now lighting up, and you have an additional button on the right. This button allows you to switch between different views. So this is the battery view. You have the grid view, which has a lot of detail, and also, of course, all the buttons that you will see here as well for charging and discharging. Now you see a identifier, the charger number and the cell number. The same is in a separate column as well. The IP address of the charger, the serial numbers assigned, and the project name. If you're running Ferrari cells with a specific project, you can basically mark them and give them a name that allows you to very easily collect them if you do multiple packs. If you're having a low voltage pack, a low capacity pack, high performance, then you want to have different cells than when you have a high capacity pack with a low performance. Now, all of these are descriptive, so you'll see the status of where the cell is into, the voltage of the cell, the milliamps that it is currently either charging or discharging, the discharge capacity, the charged capacity, and the internal resistance of the cell, the temperature per bay, the runtime, and then these are the parameters that you have set. This is the discharge cycle it's currently in, and this is the discharge cycles that you've configured. So you can see mine is configured for one charge discharge cycle when we're doing a capacity check. But once we change this to, for instance, I want to run it like 3 times, you hit apply, and you see that this counter is now set. Okay, and we're going to run a capacity test 3 times, and it's very easy. Then when you want to rejuvenate one of the cells that are bad, you see that the first charge will not give you the correct capacity. So the second discharge charge cycle will make it better, and the third one is more representative. And then of course we have the buttons here like the charge discharge, and you have the ability to change parameters on cell level. Meaning that if you want to digress from the default, if you want to have this specific slot of your charger not discharging to 3 volts but to 3.3, or charge it to 4.2 instead of 4.1, then you can set that as well. Now, my recommendation is this is already for, as I said, advanced features, because if you not paying attention, and especially when you have adjusted the view to hide certain elements, let's hide a few of these items, then you see that in here there is no view anymore on what was the voltage set to. And when you go into your charger parameters, you'll see that it reports 4.1, but actually that particular slot is now configured for a completely different voltage. So when you're changing it
on a cell level, please make sure that you keep a good eye out on what you're actually doing. Okay, let's have a look. Where were we? So advanced view. Of course, we have also the hybrid view, and we have and the charger and the data grid, and of course we have the what we call the Megacell factory setting, which is a specific setting for one of our customers who's running like 40 plus of these chargers. They're charging like a couple of thousand cells on a daily basis, and they want to have a specific view which is for their factory line preferred. So this one you'll not see, and of course you have the last one is I don't want to see anything. I just want to keep it running. I want to have as little overhead as possible, because every graphical user interface will have a certain overhead on CPU and memory consumption. So when you don't want that, you can basically disable all the views, and you'll see that the application becomes really calm. And the reason for that is, especially with the factory customers, is they're not used to viewing all parameters. They just want to get the label from the printer, stick it onto the battery, put it in the box, and put a new one in, and basically run through their charge, discharge, capacity test cycles. Okay, this was the overview of the main window, which is not visible here, but it's hidden under the main application icon. If you double tap it, it'll show up a log, and here you can see what is actually happening in the application. Now this is for debugging purposes, but it's one of the hidden features that is in the application, that in case you have some issues, open up this view and you can have a look what's going on. It shows when it's actually pulling an update. It'll show you what parameters are pushed, what is received, etc., etc., which might help in finding issues down the line. If you want to take a look at it, great, but otherwise you can always take a look at the log files in the Connect and Exchange folder. They are actually the same as you can see here. It just pushes all the data which is in this file also into the view that you have. So when you are in any issues, you open up a service request with us, please make sure that you zip all these log files and send them across. So the configuration page in a little bit more detail. Now we've already discussed a few elements. The minimum voltage is the voltage it discharges to. The store voltage is the voltage that it will charge to during a capacity measurement cycle, and at the end of the cycle it goes to this particular level. It's variable. You can change this to anything you'd like. Default is set to 3.7. And then we have the max voltage, which is the voltage that you're charging your cell to during either a charge cycle or a measured capacity. Now the discharge is variable. You can set this value from 200 to 1000. Anything below will result in an error. You see the text box changes to the color red. It'll not accept your input, and you need to make sure that you stay within the value range, also shown here in the log window. Now the max temperature is the temperature where the system will say this cell is bad. And during a charge or discharge cycle, you might have a heater, and that heater is going to be detected when the temperature probe on the PCB reaches 40 degrees centigrade. Now this value is adjustable. You can set it also to 20, or you can set it to 50, but you need to be aware that this value is dependent on your ambient temperature, which means that if you're in, let's say, Alaska, and it is like minus 20 degrees in your battery shed, first of all, don't charge batteries that are below 5 volts, below 5 degrees, because that's bad. But let's assume that it is the case and your batteries are on a certain temperature level. Measuring it for 50 degrees won't work. So what we've noticed that during summer and winter, when the ambient temperature changes of your loading shed or wherever you do your work, will have an impact on when a heater is being triggered. So by default it's set to 40 degrees. During winter you might want to change it to 35, and in the summer you change it back to 40. So it's something that you need to check on, like what is your preferred value. Anything above 50 degrees is not accepted. Batteries that are reaching 50 degrees are very close to the maximum temperature of the electrolyte, which is around 60-65 degrees. Then you get into serious trouble. So we've decided to cap this max value to 50. And if you want to do charge cells that go beyond 50 degrees, then please don't use my product and use another charger, because you could damage either the charger or your environment. So be cautious what you're doing. Will I change the max values? No. These are based on experience, and if you want to do anything outside of what I deem safe, that's up to you. But don't bug us with ridiculous requests for values. They will be denied for your own safety and the safety of others. All right, so you can configure your discharge cycle between 1 and 100. That's needed to rejuvenate your cells that have been dormant for quite some time. Values 1 to 100. Anything goes in with 3 is normally the default that you're using. I'm always setting it for 1. Mine are already tested by a supplier. I'm only retesting all the batteries just to make sure that there are no outliers or mistakes on the vendor, especially for recycled batteries. Now you see here also the charge correction factor in a percentage. And that is added in this release, so it allows you to adjust the megacell charger values to match a reference charger. Now you'll see that if you take a Liticala or an Opus or an RC, they all are doing things differently. They have different ways of charging, different ways of measuring, and there's always a variance. Now if you have a reference battery, you chuck it into a Opus or a Liticala or an RC or whatever you have, and you measure the capacity, you put it then back into the megacell chargers, do the same with the same min voltage and max voltage parameters, and be aware of those values and set the correct milliamps. Then you could compare the value from your reference charger with the megacell charger. Now once you have that, you can calculate the difference in the percentage, and that percentage can be added here. So let's say the charger is 10% off. You can choose to do a charge correction of 10% if it's too low, or you can do a minus 10% if it's too high. This allows you to match your megacell charger with anything that you have currently running in your environment. Now, as a beginner, leave these parameters to just 1. And you'll be fine. Now there's also a tick box here which is chip control charging. There's a lot of discussion going on, but I leave the name as this. And chip control charging basically means that the software will mimic the same parameters as a Opus charger. And that will bring the actual charge of the batteries very close to what you see in a Opus when it comes out of the box. Now I say very close because every charger has its own variance. Hey, you know that components have a tolerance. Opus chargers have exactly the same. When you take one Opus and compare it to another or to an older model, all the values are always slightly different, so it comes very close. When you start charging batteries, leave this one to chip controlled. And if you're more advanced, you can change the max voltage to your likings. There is a max value. You can't go beyond 2.5 volts. Sorry. You can't go beyond 4.25 volts because that is deemed too risky. So if you set it to 4.26, it will show you that's not possible. You need to lower that value. But in general, what we've measured with little Kalas and with Opus chargers is that they have a charge voltage of 4.24 volts, where actually then the curve is flattening off until they stop charging at 50 milliamps. So we have 100 of a volt extra for you to play around with. Now, already notifications, printer settings are already discussed, so I'm not going through them. Now, if for whatever reason something went completely wrong, and it can, when you, for instance, change your screen sizes or your screen positioning, the application might put the windows outside of your view, for instance, like this. Let me see if I can even put it here. Then you won't be seeing it anymore, and yeah, you might be struggling like, okay, where are my windows? What you do is then hit the red button which says reset app settings, and it says, are you sure you want to do this? You say, and now the application is actually cleaning the configuration database, and when you restart the app, it will be completely back to its defaults. So that also means that you need to add your chargers back into it. Now, the charger settings are stored on the charger itself, so those will be recovered, but all the other parameters and settings are completely cleaned off, allowing you to basically recover without having to go into your database and start messing around with the system. And as you can see here, everything is back to where we left it. All right, that's it for the basic configuration panel. So we've set everything up, the basics are in. Now we have our charger overview, and I've just added a single battery in the charger. And if you're hovering over that battery, where the actual color is, or the capacity, it opens automatically a pop-up, and you see that this is charger 1, cell 8, and the charging parameters. And currently there's no cell full drop measured or full drop or test cycle that you've performed on this particular cell. So on top of the charger, you'll see the IP address, and that allows you to easily identify which charger belongs where. Now, there are two buttons that you can press. You have the options button here, which is doing exactly the same as on your actual charger. It has the charge, discharge, capacity test, store, charge, stop, and the workflow enablement. And there is the reset button. Now, if you're in a state that you don't know what is happening anymore with your charger, and you want to make sure that everything is back to a fresh startup, power up, you can press the reset button, and it automatically starts resetting your charger. It'll also stop all the charge, discharge, capacity test running at that point of time. And you need to give it a minute or so to recover, and it'll come back. As you can see, it says now I'm offline, and here you go, it's back. And you see that this cell that I just inserted is also visible again. Now, the chart will continue up until the point that you give it a command. Now, there are two ways to send commands. I already discussed, you can do it through the main window, but you can also do it here. So you can right click the cell and select charge. Now, once you select the charge, it'll send the command towards the charger, and it can take up to 5 to 10 seconds before it responds. It's running on a cycle. Every 5 and 10 seconds it sends commands to the charger, and as you can see here, the light turned on, which means that charging commenced. And you can also see in the graph that the voltage jumped up, and the charging milliamps is around 1000. This bar will eventually go up and the more capacity goes into your cell, and through the various menus you can decide, okay, I want to stop this process, or I want to start discharging, etc, etc. So that is it in a nutshell. There's nothing much to it. You see the voltage of the battery in the battery cell itself. And you can of course see here what happened with that particular cell as well. Okay, so let's see what happens when we do a capacity test. And I will speed this one up for the sake of time. But yeah, it gives you a good overview of how it looked like in real time. Workflow is completed. You see the green sign that it is done, and when you hover over the lower bit of the capacity, you will eventually see the graph pop up, and it shows the 1435 milliamps capacity after measurement. Now, when we are looking for more details, you see also that the cell serial is generated. The same values are visible in the database. And now when we pull up the graph, you can actually also see what happened with this cell during the charge cycle. Now, in full screen mode, it needs to render a little bit, and I'm running this one on a virtual machine. And what you see here is you start your charge amps. This is a 1000 milliamp charge. And you see a very steep incline of the voltage in the beginning, which is absolutely normal. Then it starts the charge process, and when it actually reaches close to the 4 volts, you will see that the amount of milliamps is dropping, where you are basically in the area of the saturation charge. Now, when that's completed, it drops down to 0, and you go into a we call a wait state for 5 minutes, where we can see what is the volt sag from the moment it was charging up until 5 minutes past the charge cycle. And you see it's currently 4.176 volts, which is an acceptable value because always there is some volt sag. After the 5 minutes, you see here that it started to discharge, and the discharge is slowly decreasing, and that has to do with the standard Ohm's law, that the amount of voltage is dropping. Voltage times voltage is equal to amps times resistance. U is I times R, yeah. So you will see that if the voltage decreases, the amount of discharge will decrease as well, which is absolutely normal. Here you have a very nice curve, and at the point of 3.3 volts, you see it dip quite quickly to the 3.0 volts. And that's absolutely fantastic behavior. This is, by the way, also a brand new cell that we're using. And you see that here the discharge is stopped. That also means that when you're configuring your battery configuration for your power wall or for whatever appliance you use, I would recommend that you stop before this steep decrease in voltage occurs. So in this case it will be around 3.4 volts that you need to stop discharging your battery, because all of this is basically, it's not harmful yet, but it is also not a healthy situation for your cell. Now, when you stop with the discharge, you see the voltage jump up, and that is due to the charging automatically kicking into the store voltage. And once it reaches 3.7 volts here, store voltage level is reached, the charge is stopped, and you see that the battery is sagging a little bit in voltage. Because it's not fully charged, and it eventually ends up at 3.616 volts, and there it stays level. So overall, this chart gives you a very good overview of what an actual battery had done, and of course the 1435 is very important for you to write down to be able to mix and match the right cells per pack. One thing I forgot to mention is the temperature curve. I take a good look at what happens during the charge cycle. If you see that the temperature is increasing too much, or you see spikes during the charge and especially also discharge, you need to consider if this battery is fit for purpose. Now this one is it's quite level. It runs at 23 degrees here, 22, and at the end it stays within the 22 to 24 degrees range, which is just absolutely fantastic. So I hope this 30-minute tutorial about the Megacell monitor is helping you guys to get set up. There will be a follow-up episode which is for some more in-depth details on how to work in expert mode, but also how to record the volt drop over time to filter out any self-discharging cells and stuff like that. Now this part is already 30 minutes. Let me know if there's too much detail or not enough detail, where to improve, because the next episodes, when we're going into the expert mode, there are many more settings that will be discussed, and also requires quite some explanation to understand what you're doing. One of them, for instance, is the 5-minute rest period during the charge and discharge. There is a setting which you configure that if the full drop is too high, it basically disqualifies the cell and marks it as bad. Now if you change that parameter, you set it wrongly, it either doesn't detect any wrong cells, or it will filter out healthy cells and basically generating false positives. So it requires some explanation what happens there. Let me know your thoughts, and if you like, give me a thumbs up. If not, then please put in the comments what we can improve for the next episode. All right, take care, and until the next episode.